last lesson, I challenged you to try example D on your own. So we're going to work it out and let you check how you did. Hopefully you drew a line down your less than or equal to if you needed to, and you inspected your inequality. And hopefully you notice there are parentheses here with a number on the outside, so that indicates you need to distribute that too. After the distribution, you can see we've got 8 minus 6x is less than or equal to 4x minus 2. And now we need to re-inspect, and we notice that we've got an x term on both sides. So we're going to move these together. Now my preference is to go ahead and add this 6x because I like adding. It's a lot easier than subtracting. I'm adding the 6x to both sides. I'm left with 8 on my left-hand side is less than or equal to 10x minus 2. And re-inspecting, I want to get the x by itself. I'm going to add 2 to both sides and then divide by the 10. Adding the 2, I get 10 is less than or equal to 10x. And dividing the 10, that will give me 1 is less than or equal to x. Now you need to be very careful. It's really a good idea to rewrite this and reverse the symbol. Another way you could do this is just what I like to say, read it backwards. X is greater than or equal to 1. X is greater than or equal to 1. So we're going to put a closed circle at 1 because there's an equal sign there, and shade it above greater than 1, adding an arrow to the end. And don't forget what this means. It means any number greater than 1 and including 1 would make this original inequality true. So that's what we've done here with this graph. On these last two examples, notice this isn't a mistake. There's no number line here, and that's because these last two examples are actually special cases. So let's solve them and see what happens. For the first one, drawing the line down the inequality, the greater than, I can see I've got a v on both sides. So I'm going to subtract the v here. So if I subtract the v, I end up with the v's canceling. And some of you might have seen that that was going to happen right away. So I end up with 1, and it cancels over here too. 1 is greater than negative 6. So what I want to do is ask myself, is that true or is that a false statement? Well, 1 is greater than negative 6. So this is true. And what that means is, we've learned this before, if our variables cancel out and I'm left with a true statement, then my answer is all real numbers, or sometimes we say infinite solutions. Now, we can actually graph this. If I made a number line, and it doesn't matter what numbers were on it, if I wanted to graph it, I would shade the entire number line. So it's all real numbers, so it would be the entire number line. For example F, let's go ahead and set this up like we always do. Line down the less than or equal to. And I can inspect and see I need to distribute that 3. And you can see now I've got 3x plus 12 is less than or equal to 3x. I want to subtract to get those 3 x's together. So I need to move those variables first so that I only have a variable on one side. And looks like I'm going to get 12 is less than or equal to. This is where you have to be careful. It's not less or equal to nothing. Nothing is a 0, so make sure you write it that way. Make sure you still have a 0. Ask yourself, is that a true or a false statement? And this one is false this time. So because 12 is not less than 0. So that means this problem has no solution. And once again, if I look at the number line for this one, you just don't shade it. Okay, so it's just not going to be shaded at all. So that the solution on the graph would just be a number line with no shading on it. So just don't shade it.